In this video, I'm going to be going through the answers to pages 161 through 166 in Module 3. Again, I did the first one with you in the last video, and I left the second one for you to do. So they're asking us to use the graph to estimate the times Deep Flight 1 will be more than 2,100 feet below sea level and more than 2,100 feet, approximately 4.5 minutes into the dive. It will be deeper than 2,100 feet or more than 2,100 feet. Again, the wording is a little weird when you're using negatives, when you're talking about depth. So just be aware of how you word it or knowing what you're looking for. It also asks to write 2B, asks to write an inequality and solve it to determine the time Deep Flight 1 is more than 2,100 feet below sea level. And so the time, negative 480 multiplied by the number of minutes, is less than 2,100 feet. If I divide both sides by 480, negative 480, negative divided by negative is positive, 480 divided by 480 is 1. So 1t, again, dividing both sides by a negative, flips the inequality sign. It now faces the other direction. So the time is greater than, and I got 4.375 minutes. How do your answers using a graph compare to those you wrote when you solved the inequality? Graphs are nice because they give quick information. They allow you to see a lot of information very quickly, but they just give you close approximations. And solving an inequality takes longer, but it gives me the exact value. And so they're useful for different things. We did page 162 together, so I won't go over that again. Page 163. What do you think are all possible values for depth in terms of this situation? Write inequalities to express your answers. The depth has to be, the maximum a sub can go is sea level. And so the depth has to be less than or equal to sea level, less than or equal to 0 feet. And crush depth for this submarine is 3,300 feet, which means if it goes below 3,300, it's in danger of imploding. The pressure from the seawater pushing in on it will pop it, and water will rush into the sub, unfortunately kill all occupants, and the sub will go to the bottom of the ocean. So it's important for the sub to stay above, at or above 3,300 feet for safety. So the depth has to be greater than or equal to negative 3,300. I wrote it this way as well. Negative 3,300 is less than or equal to depth, which is less than or equal to 0. Examine your table. What do you notice about each depth in relation to the one before and the one after? The value before is 650 feet less, and the value after is 650 feet more. So, for example, right here, number 1, the value before is 650 less. The value above is 650 more. In this problem, what is the unit rate of change? Again, unit rate is it's comparing units, and the denominator unit is per one of that unit. In this case, we're talking feet per minute. So how many feet is this thing changing in every minute? Well, it's going up. So positive 650 feet per 1 minute. And this 1 down here is what makes it a unit rate. How deep would the submarine be after ascending? Again, ascending is going up for 2.5 minutes. I'm going to put 2.5 in for my time. 650. I'm using this equation. Depth is 650 multiplied by time in minutes minus 3,300. So I'm going to use this equation each time. And I'm just putting in this, some unit, some time, and solving for depth. Depth is 650 multiplied by 2.5 minus 3,300. 650 times 2.5. 1,625 minus 3,300 is depth is negative 1,675 feet. 90 seconds. In an earlier problem, our previous page, 90 seconds is a minute and a half. We already found that. Depth is 650 times 1.5 minus 3,300. 975 minus 3,300. Depth is negative 2,325 feet, or 2,325 feet below sea level. I could have written it either way. 45 seconds, again, a previous problem, we already found out that that's 3/4 of a minute, 0.75 of a minute. So I'm putting 0.75 in for time. 650 times 0.75 minus 3,300. 650 times 0.75 is 487.5 minus 3,300. And again, the calculator is very useful here. Depth is negative, I should have a negative sign there, or say it's below zero. Negative 2,812.5 feet. And then, in this case, they're giving us depth, and they want us to find time. They're giving us a depth of 1,000 feet below sea level. 1,000 feet below sea level is 650 times t minus 3,300. I need to get t all alone. Add 3,300 to both sides. So again, addition property of equality. 3,300 plus 3,300 is a zero pair, so that just became a zero. And I have 2,300 is 650t. Divide both sides by 650, division property of equality. 650 divided by 650 is a fancy 1. 1t is approximately 3.54 minutes. And I used my calculator. Letter B, 2,100 feet below. So when D is negative 2,100, negative 2,100 is 650t minus 3,300. Add 3,300 to both sides. Simplify. Divide both sides by 650. Simplify. And I get t is approximately 1.85 minutes. I had to round. And sea level. So when depth is 0 feet. So 0 equals 650t minus 3,300. Again, I added 3,300 to both sides. I divided both sides by 650. And I have t is approximately 5.08 minutes. So just a little over 5 minutes. If there's questions on any of these pages, again, please get a hold of me. You can go back through the video and look it over, but make sure it's making sense. And if not, contact me. Use the information to construct a graph for this problem. First, label the units. I put in my units, depth in feet, time in minutes on each axis. Then plot the points from the table from question 7 and 8. Finally, draw the graph to represent the problem situation. So, the table, when x is 0, when time is 0, depth is 3,300. Well, this line would have been 3,325, so I need to be just a little bit above it. 0, 3,300. And then when x is 1, y is 2,650, negative 2,650. When x is 2, y is negative 2,000. When x is 3, y is negative 1,350. When x is 4, y is negative 700. When x is 5, y is negative 50. And again, my independent, my x value is time in minutes, and my dependent value is y, and that is in depth in feet. Draw a box or oval on the graph to estimate each. The time deep flight 1 is above 1,000 feet below sea level. So at 1,000 feet is approximately here. It's after 3.5 minutes. So any time after approximately 3.5 minutes, the submersible is above 1,000 feet. And the time deep flight 1 is below 2,000 feet sea level. So 2,000 was at 2 minutes. And everything over here, anything prior to 2 minutes. So from 0 to 2 minutes, it's below 2,000 feet. Write an inequality and solve it to determine the time deep flight 1 is above 1,000 feet. So when this is above 1,000 feet, negative 3,300 plus the 650t is above 1,000 feet. I added 3,300 to both sides. I divided both sides by 650, and time is greater than 3.54 minutes. So a little bigger than a half. So it's not perfectly 3.5, but at 3.54 minutes, we're above 1,000 feet. And how about below 2,000 feet? Write an inequality. So our sub is below less than 2,000 feet. Again, I add 3,300 to both sides. I divide both sides by 650, and I get time is less than 2 minutes. If you've ever, like an old expression is dig deep enough in the ground to reach China. My grandparents live in Burbank, and the soil down there is really sandy. It's easy to dig. And so my sister, my cousins, and I used to go out in the backyard and dig down in the sandy soil and find shells. And we were always convinced we could keep on digging and we could dig a hole deep enough to reach the other side of the earth. Well, that wasn't going to happen. But my grandparents had great delight in watching us dig down a few feet and tire ourselves out as we found shells, and then got bored with digging and moved on to the next project. And I think my poor grandfather got left to fill those holes each and every time. But we were always convinced each and every year we'd go and start digging down and dig a little deeper. So if you've ever heard the expression, if you dig deep enough, you dig to China. Well, if that might be true if you lived in South Africa or South America or Argentina. If you live in the United States, especially Red Bluff area, we'd pop out in the Indian Ocean somewhere off of Madagascar if you dug straight through the center of the earth. And again, technically, you're not digging through the center of the earth, but let's just pretend. Suppose you're digging at a rate. You're going down at 10 feet per day. So every day I drew my little person up here digging dirt, and after one day they've gone down 10 feet. Identify the independent and dependent quantities, their units of measure, and define the variables for these quantities. Depth in feet, I'm going to let it be D, and that's my dependent. Again, on an axis, my Y value is my dependent. And my X value will be my independent. These go by different names, domain and range, independent, dependent, X and Y, and there are several other names that you can call them that I can't think of at the moment, but they all mean basically the same thing. You just use them in different portions of math. Similar how addition and sum mean the same thing. Write an equation to represent the depth of the hole, where D represents the depth in feet, T represents time in days. Well, our depth in feet, and we go down 10 feet per day, and our time is time in days. So that equation would work for that situation. Well, there's 365 days in a year. Write an equation to represent the depth of a hole, where D represents the depth in feet and T represents the time in years. Ooh, okay, so I've got to change this now. We're no longer doing time in days. It's now if you're going at that rate, 10 feet per day, how deep do you dig in a year? Well, 10 times 365 is 3,650 feet in a year. So your depth in feet is negative 3,650 times T, where time is in years. So if you could maintain that pace for a year, that's how deep you would go. Use your equation to complete the table. Well, again, my time they're doing this in years, so I'm using this equation up here. Time is going up by 1, and my depth is going down by 3,650. And so 3,650, 7,300, 10,915, 14,600, and negative 18,250 after 5 years. And you can use a calculator to figure this out. Just keep subtracting 3650. I can put in any number of years, multiply by that, and find my depth. Write an inequality and solve it to determine the number of years the hole is more than a mile deep. There are 5,280 feet in a mile, so we want to know when we're deeper than 1 mile. So a mile deep is negative 5,280, and we want to be greater than that. So negative 3,650 t. Divide both sides by negative 3,650. Dividing by negative changes our inequality. It flips it. Because negative in math also means opposite. And the opposite of less than is greater than. And then I used a calculator, and I get t is less than 1.45 years, or 1.45 years is greater than t. Number 6, actually 6 slowed me down. I wish I had seen this one so I could have discussed it prior to turning you loose on it. I'll be curious to see how you did, if you were able to look it up and find it. This one is a tricky one in my opinion. Write an inequality and solve it to determine the number of years the hole has not reached the other side of the earth. Well, how many feet is it to the other side of the earth? I did a Google search, and Google told me it was 7,917.5 miles is the diameter of the earth. And then I took that number and I multiplied it by 5,280 to get feet. And it's 41,804,400 feet to the other side of the earth. So I put that many feet in to my equation, and now I'm solving for t. And I divided both sides by negative 3,650. Again, dividing both sides by a negative made me flip the sign to its opposite. And I got time is in years, or t is greater than that many years. 11,453.26. So if you could dig at a rate of 10 feet per day, that's how many years it would take you to get to the other side of the planet. So if you started today, you'd finish in 11,453 years. Good luck with that. All right. So that is those pages, answers to pages 160 to 166. Good luck on those. I hope those made sense. If they didn't, please contact me. And then take the edge elastic that goes with it. Thanks.